Hi, I'm Paul Kyogan from GK Tuition, and in this video I'm doing a little bit of trigonometry, a little bit of area and volume. Now the question we're going through here is 2018 paper 2 question 8. We're given a fairly complicated, intimidating looking diagram at the start, but for part A the only thing that is relevant is the right angle triangle or QP. It says to use Pythagoras' theorem to find the distance ORQ. Well, if you know two sides in a right angle triangle, it's relatively straightforward to get the third side. If I was subbing into Pythagoras here, I could say that the PR squared plus RQ squared equals the hypotenuse squared, which is PQ squared. And I've displayed that in this line. If we now sub in, you just get 6.5 squared is equal to 3.3 squared plus RQ to be squared. And when you manipulate this one down, it's relatively straightforward, and your final answer you end up with RQ is equal to 5.6 meters. So I now know that the distance from R to Q is 5.6 meters, and for the second part of this question, again, we're only concerned with this triangle. For part B, it asks me to find the angle alpha. Now, if you have a right angle triangle and you're looking for one of the angles, you're going to be dealing with either sine, cos, or tan. In this case, you can use any of those three because you know all three sides. I've decided to use the formula for sine. Sine of an angle is opposite over hypotenuse. So if that's my angle alpha, 3.3 is the opposite, 6.5 is the hypotenuse. So if I just sub into this formula, I can say that the sine of the angle alpha is equal to the opposite, which is 3.3, over the hypotenuse, which is 6.5. I want to get alpha on its own. So if you bring the sine to the other side, it becomes sine inverse 3.3 over 6.5. And you should just be safe, make sure you realize that's its sine inverse of all of that. If you place that into your calculator, your answer for alpha works out as 31 degrees, and that's what they asked you to show, so you know that you're on the right track. Okay, for part C, it says to use alpha in order to find beta. Well, you should realize that in this diagram, clearly those two angles form a straight angle. So the angle alpha and the angle beta form a straight angle, and a straight angle is 180 degrees. So in order to work out beta, it's just 180 minus the angle alpha, which was 31. So you know that beta works out as 149 degrees, and that's your answer for part C. Okay, for part D, it says to use the cosine rule to find the length of RS. In order to find the length RS, then clearly the triangle we're dealing with is the triangle RQS. I know that that distance is 5.6, the angle beta is 149, and this distance is 8. So that's enough information to use my cosine rule. The cosine rule is that a squared equals b squared plus c squared minus 2bc cos a, where capital A represents the angle that you're dealing with. So the capital A in this case, my angle is 149 degrees because it's the only angle I know in that triangle. If that's the angle, if 149 is the angle you're using, you have to sub in the opposite side as the side A. So that side has to be my A. So because I'm using that angle as 149, the right hand side, what goes on its own, on the left hand side is the distance RS. That's opposite the angle, so that's my A, and then B and C are interchangeable. So we can call 5.6B and 8C, or we could do it the other way around, it doesn't matter. So if I sub in there, instead of A squared, I'm putting in RS to be squared. Instead of B squared, it's 5.6 squared. Instead of C squared, it's 8 squared, minus 2 times 5.6 times 8 times the cos of 149. Now on the right hand side, they're all numbers. So you can just plug that straight into your calculator. You plug it all into your calculator, you get RS squared is equal to 172.16. In order to get RS on its own, I get the square root of both sides, so RS is 13.12 meters. But the question asked you to leave this to the nearest meter, so your final answer for that bit is that the distance RS is 13 meters. Okay, for question 8, part E, we're told that SQT is a sector of a circle. You should just think of a sector of a circle as like a pizza. If you cut a slice out of a pizza, basically what it means is that Q is the center of the circle. Imagine if this was a full circle. This is a slice of pizza that you've just taken out. So Q is the center of the circle and S would be at the edge of the circle, which means that the distance from Q to S, or the distance from Q to T, is considered the radius. So that would be considered a radius of a sector. Now, I didn't refer to this in the previous part, but if you look at the overall diagram, the angle here at Q is vertically opposite the angle that was the angle alpha. So alpha and this angle have to be the same because they're vertically opposite angles. So we worked out that alpha was 31, which means I know that this angle is 31. Now this question has asked me to find the length of the arc from T to S. An arc refers to just this section here, the edge of the pizza slice, or the edge of the sector. The formula for the length of an arc is on page 9 in the log tables, and it's given as 2 pi or times theta over 360. You'll notice in the log tables there's two formula for the length of an arc. There's another formula that you use if we're talking about radians, but clearly in this case we're talking in degrees, because I know the angle in degrees is 31 degrees. So you can ignore the other formula on page 9. The one you're concerned with is 2 pi or by theta over 360. And as I explained a second ago, we can consider the radius to be the distance QS or the distance QT. So the radius of this sector is OR, and theta is the angle in the middle of the sector, in this case 31 degrees. So I can get the length of this arc by just subbing in OR is 8 and theta is 31. If you plug that into your formula, your final answer, the length from T to S, is 4.3 meters. The final part of this question asks me to find the area of the sector. The formula for the area of a sector is on page 9 in the log tables, and again there's two of them, but the one we're concerned with is the one that pertains to degrees, because clearly my angle here is in degrees, it's not in radians. So the area is pi or squared by theta over 360. The radius is 8 and the angle is 31 degrees. So if you just plug it in, your answer works out as A is equal to 17.3 meters squared. It asks you to leave it to one decimal place, so happy days, that's your final answer. Now I hope all of that video makes sense. If there's anything you're unsure of there, or you'd like me to clarify it, just send me an email or let me know in class and I'll explain it a little bit differently.